gentlemen, tell me when you're ready. Okay. Enga mana, enga reo, e ro rangatira mā, ki te mana whenua, Ngāti Whātua o rāke, e mihi ana mō tō koutou manaakitanga. E mihi ana, e mihi ana. Ko wai au, ko maunga tapu, te maunga, e ru nei taku ngā kau. Ko maitai te awa, e mahea nei āku maharahara. No wakatu ahau. E mihi ana ki ngā tohu o nehe o wakatu I tipu ake au. Ko Rosalie Nelson, tōku ingoa, ko Chief Executive, Edmund Hillary Fellowship and Hillary Institute. Aho. Welcome, welcome, welcome. And greetings to all of you, those in the room, but also we understand there is about 70 of you online as well. And we're incredibly privileged to have people joining us across many regions, New Zealand, Australia, the Philippines and the Pacific Islands. So we do thank you all for your time, for the important mahi of space for planet Earth. First, and I know everyone loves this, the health and safety instructions. The location of the nearest toilets, just go out the door. The male tane toilets are first, the wahine just further on beyond where the lifts are. In the event of an earthquake, drop, cover and hold. And if we do need to evacuate the building, follow the instructions of staff or host and proceed to the nearest safe exit. Now for us, this is pretty straightforward. It is literally that door there. It will take you down to the front and then you can muster outside. So tonight's event, we believe is a really important one. Space for Planet Earth's purpose is to leverage space data to address critical climate change issues today in New Zealand, Australia, Philippines and the Pacific Islands. And the ambition here is to inspire the next generation to create innovation that can contribute to solving the biggest environmental issues we have today through incentive prizes. Look, I'm not going to tell you, that all of you will know just how incredibly important this is. The first reason is that climate change is the defining challenge of this age. And if you read the IPCC reports, we have just 75 months if we are to confine temperature changes to within a kui of 1.5%. New Zealand, Aotearoa New Zealand is going to be challenged in meeting its targets, particularly if it doesn't address methane, which is round about half of our emissions alongside CO2. What we need here is not just technology solutions, we really need systems change, and that requires collaboration. Our climate challenge is urgent and interconnected, and it's no one sector, no one actor, no one entity that has the solution. It does require enormous collaborative effort and fresh ways of thinking, innovating and acting. In other words, systemic challenges require systemic responses. So that means that it is critical that we inspire and empower a new generation to act, and that all of you in the room who are not part of rangatahi, that you bring your skills, your connections, your knowledge and your resources to serve that. We are at risk for a generation that will live with a dystopian narrative about what the future holds, and that can mean a loss of hope. So if we can inspire, if our rangatahi can see pathways and grounds for optimism, this gives agency. So this challenge, Space for Planet Earth, is so important if we are to shift the narrative and inspire for the future. So the program agenda, this is an opportunity. And I'm sure you want to see everybody, but I'm just going to see if I can find, don't worry. The program agenda, look, this evening is an opportunity to learn from experts about the problem and the current space data tools that are beginning to address these issues, and also to understand the process of participating in the challenge. And also, I feel very honoured to be able to speak here today. I was invited to by Emmeline and Eric. They are a part of the Edmund Hillary Fellowship, so I have the privilege of serving the Edmund Hillary Fellowship and the Hillary Institute. The Hillary Institute has 11 extraordinary international laureates who are globally recognised leaders in climate. So Johan Rockström, one of the foremost climate scientists who define planetary boundaries. Vanessa Nakate, who at 26 is one of the leading voices in the world today about loss and damage. And Christiana Figueres, who was the architect of the Paris Accord in 2015. The Edmund Hillary Fellowship has over 500 change makers, innovators, creatives, investors and technologists who have been attracted to Aotearoa, New Zealand, and who believe this place can be a base camp for global impact. So it was actually the fellowship that was the genesis of the space-based project with Emmeline and Eric amongst our first cohort. So just huge tribute to Emmeline and Eric and all the work that you have done. Just as a little side note, I'm very happy to talk to any of you about this later. We are also preparing to launch our next expedition, which is the Mission Studio. And the concept of the Mission Studio is to do exactly what we've been talking about. How do we gather all the key parties in this country around climate innovation and bring us together in a way that not only gets us talking and defining the missions and what we need to do, but also bringing capital, knowledge, connections in service of that. And the studio will be the connective tissue that helps to bring that together. So we see great alignment between Space for Planet Earth and the work of Emmeline and Eric. So it's a real privilege to be with you all here today. I'd like to introduce now our first speaker. And this is Pam Ford, Director Investment and Industry for Tataki Auckland Unlimited. Pam, she leads the Investment and Industry Group for Tataki Auckland Unlimited, which is the region's cultural and economic development agency. Look, there is so much that Pam has done, but I also just want to pay tribute to her as an extraordinary leader and voice in this country, who's absolutely passionate about the future for Tamaki Makaurau and the change that we can show for the rest of the country. Welcome.
Thank you, Rosalie. Tēnā koutou katoa, ko Pamela Ford aho, as you've heard. I'm Pam Ford and I'm head up the economic development part of the economic and cultural agency in this fine region of Tamaki Makaurau, Auckland. So a very warm welcome to everybody online, those in the Philippines, in the Pacific and Australia. And certainly to each of you in the room here, it's wonderful to have this chance to say a few words. Emmeline emailed me about this time yesterday and said, how about doing an intro? And I said, yes, of course, Emmeline, I could never say no to you. And there's nothing like a short notice to have something very short and sweet you'll be pleased to know. The Economic Development Agency that I'm very proudly part of, we care deeply about the future of our city, of our region, of our country, and indeed the Pacific. And so we focus on sectors of the future. Our people, we are a very young city relative to other regions, and it's great to see some young people here tonight. But 40% of Auckland's population is youth, and a large proportion of that is Māori and Pacifica. And of course we focus on our environment. So that is why we're very involved in space and young people and climate change, and each of them play a critical role for our city. Auckland, as you know, is the largest city in New Zealand, and as an international gateway, we were recently highlighted in MB's Startup Council report that's the only region in New Zealand that has got the characteristics of a global ecosystem, and where Auckland has 1,400 of the 2,400 startups, and New Zealand having had 600 million plus exits in the last 5 years. So for Auckland, what we need to do for our ecosystem and for those companies that are working in the space startup arena, the report says that we should be fostering connections with the global ecosystems to local startups to help develop world-leading unicorns and help the startups go global with investors that think local. And so that's why working with the likes of Rosalie at EHF and her wonderful network of global leaders and working with, and that includes Emmeline and Eric. And I remember when the first cohort was announced for EHF a few years ago now, wasn't it, Rosalie? And Emmeline and Eric were talked about, and we were like, this is incredible that we can attract people of their calibre to New Zealand. And so all of us here in this room are so lucky that you two have chosen to make New Zealand your home and then allow us to engage in a competition, a challenge such as this. So I want to pay special tribute to the two of you. We're also here, our agency is very involved in the Auckland Aerospace group, a cluster, so we put a lot of effort into that, and some of you are probably part of it, working with the University of Auckland and many others. And in fact, the other day, the National Party spokesperson for tourism, a guy I'd never heard of, his name's Joseph Mooney, he's based in Queenstown, came up to speak to me about tourism. But it turns out that he's also the spokesperson for space. So we talked about tourism for about that much, and we talked about space for about 95% because we both kind of geeked out on it. So it was good to hear how interested someone that's in Parliament is pushing all space. I'm really excited about the 2023 challenge, which I know you'll hear more about later, and you've got some really exciting speakers. But talking about using satellite data in combination with other data sources help develop scientific methods to identify target areas of methane emissions on Earth. Methane, as we've just heard, accounts for about 50% of the emissions in New Zealand. In Auckland, it's about 3%, because despite Auckland being a region that's 70% rural, we don't have too many cows. So, however, we have our real problems in terms of transport. That's our biggie for emissions. And also the built environment and energy and food. And to that end, we launched in October last year Climate Connect Aotearoa, which is a climate innovation hub, which it is in the process of starting up challenges around those 4 areas and accelerating innovation for the climate. So at the moment, Climate Connect Aotearoa is an incredible website being added to all the time. It's a connected community, and we're building up partners, including EHF, and we're working on these challenges in those particular areas. For all of you now, you need to just focus on methane and get stuck in, get involved in this challenge. It's going to be super exciting. I can't wait to come back in March and next year and see who are the finalists and who's going to win. Encourage you all to really lean in, form your teams, explore and experiment. And I note that the winner of the last challenge in 2021 was from Suva in Fiji. So Nisa Bulafanaka, I hope you're online now. Just to end, my partner is Fijian and a science fiction writer whose latest book is based in space with Pacifica characters. It's called Navero, which means whirlpool, and it's all based about a whirlpool in space. And so on that note, it's also the Auckland Writers' Festival kick-off tonight and the gala, so I need to head off to that event, and I will leave you with this warmest of all welcomes to Tamaki Makaurau, Auckland, and all the very best for the challenge. Thank you, Emmeline and Eric, and everybody else behind Space-Based Challenge, and look forward to following the challenge over the next 9 months or so. Tēnā koutou katoa.
Pam, thank you so much. So now we're going to introduce our next speaker. And just to pick up on the points that Pam was making, the challenge focus area this year is on the identification of areas of methane emission using satellite data around the world. Now, New Zealand Space Agency, which I think is still pretty new, I think it was founded about 2016, if I'm right, has been focused on addressing methane emissions through the support and collaboration of methane sat, that's a good mouthful, a methane sensing satellite scheduled to be launched early next year. So the goal of this challenge is to leverage the data from methane sat via the solutions the teams will come up with in the competition. So, to tell us a little bit more about this is Tim Searle, Principal Policy Advisor for the New Zealand Space Agency. Now, Tim is a space and high-tech expert specialising in market validation, strategy and due diligence. And he's had a lot of experience across both government and also in the private sector. So today he's a Senior Policy Advisor at the agency at MB. And he's also designing an investment framework for sensitive and critical technology R&D with a view to investing in space and energy technologies through innovative partnerships. Tim.
Thank you very much, Rosalie, and thank you very much for having me, Emily and Eric. Emily and Eric have been supporting the New Zealand space ecosystem for a long period of time and have had a pretty measurable impact in Christchurch, and now we're happy to support them here in Auckland. So I'm really thank you guys for the effort you've put in so far. I thought I'd just, methane set is what I'm principally here to talk about, but I thought I'd just preface for the people that haven't heard this. So the people that do know this, please feel free to zone out for the next 2 to 3 minutes while I describe where I come from and why we're here. So I work for the New Zealand Space Agency, which is a part of MB. We have three critical functions within MB that we perform, but we're part of a sort of wider science ministry, so that's where our backing comes from. We have the regulatory system that you guys might know about and probably interface with more. We regulate everything that goes into high altitude and outer space from New Zealand. That includes all of the rocket lab launches, which you might know about, but also all of our high altitude balloons that NASA launches out of Wanaka, some of the high altitude pseudo-satellite work going on in Christchurch, and space planes. So anything that flies above the CAA's regulatory level, or the Civil Aviation Authority, we regulate. And in normal regulatory systems, things move a bit slowly. If you're familiar with building markets or something like that, things move at sort of a glacial pace where we change building materials, well, in New Zealand not as often as we should potentially, but not always as quickly. But space industry changes on a very, very rapid basis. I think since I first started working in the space industry in 2009, there was almost no commercial industry and there was no companies, and the work I was doing was buying data of large governments who had assets there for other purposes. And now 14 years later, things have completely changed and we are in a completely new environment, and I'm glad to see that New Zealand is one of the countries that really has a high commercial focus. So the third thing that I am most involved in is we do technology partnerships with other countries. So we have a long-standing partnership with DLR that has been running since 2019. We will soon start our work with NASA, that we have had partnerships actually through Glenn Willoughby as one of the sponsors for our NASA internships. We had NASA internships running for a while, but now we're entering into joint technology partnerships, and one of the key areas that we are partnering with NASA in is on climate and how we address that. So it fits in well with our wider range, and the other country that we're looking at partnering with is Australia on climate as well, and that's largely looking at New Zealand, Australia, and the Pacific. Okay, so I might skip through this because the methane set work is far more important, but one of the areas that New Zealand doesn't have huge budgets in work, but where we do have a substantial lever is policy development. So those of you with a keen eye might have seen that we just released our policy on active debris removal yesterday or the day before, and we're going to regulate a mission that is going to start to look to remove some rocket bodies and other debris from the low Earth orbit environment, and that first categorization mission, ADRAS-J, from a company called Astroscale, will take place in July, I think, this year, from latest thing. But we have a range of other policies, and that's our big way into, I guess, global space challenges. And we have some research agreements that I talked about earlier, but the main one is there in the middle, and it's methane set, which is New Zealand's first and only involvement in the space mission from the civil side that I know of. We are very proud partners in the methane set mission. Sorry, I should have got these slides also in front of me. But it's we are also a critical partner, so I'll talk about the ways that New Zealand is involved in the future. And it's really great to see that the space-based challenge this year, and Space for Planet Earth challenge, is so involved in supporting this mission and supporting the user uptake, because the MethaneSat mission overall has some quite lofty goals. They want to reduce the methane emissions by 45% from the oil and gas industry, and that's mainly through accountability. So the data that all the data that's produced from this mission will be made open and public. And I'm pleased to say that New Zealand is leading one of the science teams for the mission, and that is on agricultural emissions. But the MethaneSat will look at different types of methane emission across the full spectrum. So it's really exciting, and we need to make sure that we are, supporting the teams as much as possible, not only from the New Zealand basis, but also around the world. So you can see some of the quite credible partners. You might recognize some names there. It's at the moment the mission was supposed to launch in 2021-22, and now we are in 2023, and the mission will launch in 2024. But I'm pleased to say that the technology development is fairly under wraps now, and there's a launch booked, and that should be, and we should be able to see some data coming from the mission in the pretty near future. And I hope that some of the teams that are competing for this challenge might be working on that for a long period of time, and helping with that big goal of decreasing emissions in the future. So what is New Zealand doing specifically for the mission? So I talked about one of the sides, and that is the agricultural emissions on the science angle, but we're also contributing through the University of Auckland, well, principally first through Rocket Lab, who will then transition to University of Auckland. That is the Mission Operations Center. So the center that will control, and I encourage those who haven't visited or haven't been to go up to the University of Auckland and have a look around. It's in the engineering building, which is in 15 Simon Street. Correct me if I'm somewhere on Simon Street, opposite the gym that they're building underground. So New Zealand will operate and control all the data and the tasking from that mission, which is quite an impressive feat. And all more impressive, I think, is that it's going to be run by a non-truly commercial partner. So it's been contracted to a university, and that's because of the commitment with this mission to make sure the data is open and public, and that people have access to it where they need it. So yeah, as you can see, the reasons why New Zealand got involved is because of the science capability, the interest in aligning with New Zealand's values, and also trying to contribute to this global goal of reducing emissions. So why methane? I'm sure this is going to be repeated a few times over the night, so I don't want to steal anybody else's thunder. I hope, David, are you going to talk about why methane is interesting? Or okay, so I'll just go over this. I'll just go over this very quickly. But one of the, and I should defer to a scientist who's an expert in this area, so I will glaze over. But essentially, methane is one of the big contributing factors to climate change, and it's one of the things that we can measure relatively easily with a range of different types of spectrometers from space. And with the MethaneSat mission itself, it will allow us to have very good accountability about exactly where those methane emissions come from. So we kind of have an idea of how much the overall methane impacts are on our Earth and our environment at the moment, but what we don't have an idea about is who those exact emissions are coming from. So part of this is to make sure that that data is open, and to be completely fair, some people might not know, or some companies might not know that they're emitting large amounts of methane, especially oil and gas producers. So it's about making everything clear and open, and making sure, giving people the chance to redeem themselves, I would say. So also not sure about how many people are going to talk about the rest of the MethaneSat mission as well. So it is an imaging spectrometer. It's primarily aimed at CH4 methane and also CO2. The difference to this, there are some other satellites with spectrometers to measure methane. What's special about this one is the ability to, I guess, when we talk about swath, it's the ability to look over a wide area and then to define that area into where the emissions are coming from. It's going to fly it's going to fly around and do quite a large number of acquisitions, so 60 to 200 targets a day it says up here, but I think it's going to be close to that 200 targets a day, and that will all be coming through that the Mission Operations Centre in Auckland that we talked about, and all the tasking will come from the different science teams involved, and they'll contact the Mission Operations Centre and say we'd like a specific tasking or a specific measurement over a specific area, and then the data will be fed back to them. So it's quite a big satellite. If we're talking about it, I think it's probably around the size of a very large fridge, 350 kilos of total payload, and so that is it's quite a considerable mass. But that also means that you have a pretty good power budget and you're able to do a lot of things with it. So yeah, there's up there's some of the other satellites, but I also note that Planet have recently announced that they're also releasing a range of satellites with quite a unique methane detecting capability in the last month or so too. So that's a short presentation. Sorry, I might have gone deeper into the science if there wasn't more experts coming up in the future. So once again, a huge thank you to Emmeline and Eric for setting this up, and yeah, I really encourage people who want to be part of the challenge to stay involved, and yeah, happy to help out if there's any way. Thank you.
Tim, before you go,
yeah.
So just talking about the methane, so it has a much higher heating impact, but is shorter lived in the atmosphere.
Yeah.
So what are the implications for us if we can deal with it? If you're sitting here and you're saying, I'd love to get involved with this, what's the potential of us addressing this?
Well, the potential is that we have these well, I guess worldwide targets, and it's a much quicker way of achieving these targets. So while we still need to address all forms of gases impacting climate change, if we can address methane, we'll be much more on the way to making sure we sit within those 1.5 degree targets.
Thank you.
Thank you very much.
Thank you to Tim. Look, a huge thank you to Tim Searle there. So that should really be a laying down of the gauntlet for everybody that is listening online. There is a tremendous opportunity here for you to think about the solutions that could really help us to address global warming in a meaningful way. So look, today's tools and satellite data have allowed us to better understand the growing climate change issues we face at a global scale. So we're very privileged to have David Noon, who's Professor of Climate Physics at the University of Auckland, join us. And he's going to give a short summary of how we're leveraging today's space technologies to address methane emissions and the gaps needed as opportunities for innovation. So David Noon is a Buckley Glavish Professor of Physics whose specialty is on understanding relationships between atmospheric wind patterns, the water cycle, and climate. He serves as Director of the Climate Systems Laboratory and Director of Strategic Engagement for Ngā Ara Whetū, a flagship transdisciplinary centre on climate, biodiversity and society at the University of Auckland. David, welcome. It's a pleasure to have you with us.
And great to be here as well, and thanks very much for the invitation to come and speak. And actually, one of the things that Tim has led into really quite nicely is this idea of some pragmatics. There are things that we can do with respect to climate change and the way we address our challenges with emissions, as well as giving some ideas about how we're addressing that. I wanted to give a bit of a flavour of the way that space and space observations inspire some of my interests in the Earth system and thinking about the science of climate and climate change, which may give some clues to how the challenge may proceed and some of the ways in which the teams might assemble around some particular problems. So I wanted to start off, it's a little pitch actually for our new flagship research centre, Ngā Ara Whetū, which of course means star paths. We're thinking of being inspired by space and the observations of space, the stars, to not only draw on the cosmological mythology of the guidance that the stars can provide us, but also thinking towards the future and thinking towards the solutions that might help us towards the futures that we choose, including with respect to the way we address climate change and the way in which we can think of understanding climate change to inform our societies of the future as well. We want to live in the future, so let's figure out the future we want. So I'd like to start off by thinking of this place. This is where I live. You can almost see where I live under this cloud. This is actually not quite real time. I took this off the website this morning. This is the operational weather satellite that the Japanese Meteorological Organization operates. We see these images every 10 minutes like this, so we can watch the updates of the weather, and we've been watching carefully over the last day to make sure it doesn't rain as I walk back to my car. That's a perfectly legitimate use of satellite observations. When I see this, I see all sorts of complexity. I see, for instance, oops, that's the wrong direction. There we go. I see spiraling cloud patterns in our neck of the woods. I see bubbly cloud patterns, the thunderstorms of the tropics. These are the monsoon rains somewhere over New Guinea and Noumea perhaps. But we also see spiraling cloud bands in the northern hemisphere as well. So we get this really global perspective of the entire system. One of the great statements that comes from early space observations, one of the very first Earth observation satellites that was launched was called TRIOS-1, and it had a very simple video camera on board back in something like 1962-ish, something like that, I forget. One of the very first things it saw as it launched out of Wallops launch facility near Washington, D.C., as it looked down, the first image showed a weather system that was otherwise not known. This was a storm that caused havoc along the east coast of the US, and without that very first image, it would have been much less obvious that it was on its way. So this idea that once we can see the world around us, we can make decisions about how we act. And thinking about how we see methane allows us to make some choices about how we act with respect to the methane emissions. One of the things I really like about my job as an atmospheric scientist, professor by day and enthusiast of nature by night or something, my other time, is to think about the sort of mysteries of nature that we see. Here's a mystery of nature. This is a satellite image of sea ice, little bits of frozen seawater around Greenland. And we can see the land there covered in snow, the coastal area where the snow is melting a little bit. And these little swirls, little ice crystals that are floating in the ocean, frozen bits of seawater, and we can see them tracing out the arcs of ocean circulation patterns, weather systems in the upper ocean. These cause changes in erosion. They're the sorts of things that bring nutrients to the surface, change the biological activity. And if we didn't have a satellite observation looking down to observe these, we may never have really seen them. They would look very different if you were in a boat. You'd see smeary surfaces. And it's only once you have that higher perspective looking down that you can really start to see these sorts of mysteries of nature. More close to home with the floods we've been having, I spend time looking out of my office window up in the other side of Albert Park there in the city, and I can look out and I can see across the harbour. After we had our storms over the last several months, including the one last week, you often notice if you look out across the Gulf, it's kind of murky and doesn't look like a great place to swim. You can see that from space. What this is showing is the Gulf. Here we have the Manukau Harbour and the Hauraki Gulf here. And with Auckland in the middle, we can see the city, but also notice the mud and smeary kind of colour in the blue. This is not the deep blue ocean that we would prefer to see. So we can actually start to see the way that our pollution is influencing our marine environments. And again, the satellite perspective here provides us some insight into the way this system is working, how our pollution is influencing our natural environment. And it might help us make decisions about, for me, am I going to let my dog swim in the water when I take her for a walk in the morning? Am I going to go for a swim in the water? Or maybe I should go and have a hike in the forest instead. These are the sort of decisions that influence our everyday activities, as well as broader strategic planning for the city as well. NASA and the European Space Agency has various constellations of satellites. This is showing sort of a time history of Earth-observing satellite missions that are going on, in this case from NASA's perspective. There's a European perspective as well, showing a variety of different satellites that are all making slightly different measurements, different resolution, different types of quantities. Maybe it's sea ice, maybe it's clouds, maybe it's methane. And these are ongoing. There's such an important need for information about Earth to make decisions that there's a need for continuity in our ability to make these measurements and always improve our capabilities as we go. I did want to give a quick shout out to a mission that's just launched from here in New Zealand. The Rocket Lab launch facility recently launched for NASA a little constellation of 4 satellites called Tropics. Is the experiment designed to look at tropical cyclones like the kind that led to the cyclone Gabrielle that hit us and other types of tropical severe thunderstorms. And New Zealand is, of course, I think one of 4, Tim will correct me, nations that really have this capability to operationally launch spacecraft. So it's a big plus for New Zealand that we were able to do this high-profile mission or be involved in the launch. What my talk is really about, though, is crustaceans. These guys. Does anyone know what this thing is, by the way? Mantis shrimp, A+ for the gentleman in the back. It is a mantis shrimp. Do you know what's interesting about this thing?
It will snap very fast.
That is one thing. They're also huge. They can get to about that long. I'm told they're quite tasty as well, so there's various things useful about them. But what I wanted to emphasize with this guy is that he can see things that we cannot see. We see about 3 colors, maybe 4 if you're generous. We can see red, blue, and green. The way our eyes have evolved, we have the capacity to measure, to observe those 3 colors, and our brain figures out, well, little combinations of those gives us a rainbow of colors. So fundamentally, we see 3 colors. They're the same colors that we've figured out to make TVs and phones with those red, blue, and green colors to match our eyes. These guys can see 12 colors. They can see ultraviolet light that we can't see. They can see infrared light that we can't see. They use this for various things. Part of their reproductive cycle requires them or is benefits from them to be able to see UV light. The way they see predators and prey can be done faster and better by the number of different colors that they can see. So this is what we can do with satellites and some of our technology. Our eyes can't see 12 colors, but we can build machines that do. And if we start looking at colors that we cannot see with our eyes, we could ask, what else do we see? Thinking of space, we see this satellite, it is a satellite observation of the pillars of creation by the Hubble Space Telescope. This is a large telescope. These days, the Webb telescope is very famous. It's the latest one. Its predecessor, perhaps, was Hubble. If we look at this nebula here, just in the visible, what our eyes can see, we see the famous pillars of creation nebula here. But if we look in the infrared part of the spectrum that our eyes cannot see, we can build machines that see infrared. We see something a little different. The galaxies behind the nebula poke out, that the light from the galaxies can go through. So just like the mantis shrimp, if we look at different colors, we can see different things. And I'm not sure we want to make terribly many informed decisions about how we manage or go through the pillars of creation, but we can make decisions about how we think it works. In the same way, we can do the same with methane. On the left is a satellite image that shows both visible light, which we can see. We can see the fields for this place in Pakistan, but we can also see, by looking at infrared light of just the right frequency, this other little plume of stuff, and that's methane. It turns out molecules, all molecules, they vibrate and rotate and wiggle in various ways. And as I'm doing this with my hands, there's a certain frequency that I can do this with. I can't really go much faster. My hands have a certain weight, my arms are a certain length. It's been a long day, this is about as fast as I can go. And that frequency is related to the exact wavelength of light that that molecule would absorb. The panel on the right here shows, for all sorts of different wavelengths, various gases: water, CO2, N2O, CH4, the 4 big greenhouse gases, carbon dioxide, nitrous oxide, and methane, which wavelengths of light that they're very effective at absorbing. So if we can make a machine that absorbs light just at the right frequency, we would be able to see that gas. And that's precisely what's done with this particular image. Here's a version of how we might see methane over New Zealand. This is sort of a little bit of baiting for the teams. This is the data which exists. There are several satellites which can already measure methane in various ways. MethaneSat will have better precision, better resolution, but there are already some capabilities for doing this, including the plume we saw on the last slide. This is from a European spacecraft called Sentinel-5P, and it has an instrument on board called Tropomi, and one of the things we can look at is where is the methane over New Zealand. So we did a very simple calculation. We just got all the measurements and stuck it on a map, and you can start to see some patterns pretty clearly. Where is the methane? What might it have been that put it there? Also, how big are the signals? What's the magnitude of the methane signal we might want to see? The amount of methane in the atmosphere, it's pretty small. It's about this scale here, I'm going to call that 2,000, yeah, it's close to 2,000, which is 2,000 parts per billion, or 2 parts per million. So if I had $1 million and I gave you two of those $1 million, that's how much methane there is compared to the rest of the air. It's tiny. And we want to measure 1 or 2 of those parts per billion, really tiny amounts. And you can see here that in these regions, which are broadly agricultural regions, the Canterbury Plains, the Waikato, and other areas scattered about here too, the methane concentrations are locally higher, associated with agricultural production. There are perhaps some gas wells operating around the Taranaki region, where we might also see some of these fugitive gas emissions, which is really the focus for the MethaneSat mission. But we can see very clearly that our opportunities to think about the technology required to improve our agricultural sector has a lot of opportunities to have an impact just from what we're already doing. Some of those technology developments are very much underway, things like changing the feed, changing the time of day you feed your cows, also doing things like ensuring that if there are wetlands on fields, they can be drained, and treating the landscape differently. All of these technological choices require data to help guide the best strategy, and which would lead to better policies on how we act. So I'll leave this component and really think about this idea of where the challenges are lying ahead. From space, we have this grand view. We can start to think about the system that we live in. We can think of our home in much more sophisticated ways with more information, where we have a broader perspective. Maybe it's a perspective on methane, but maybe it's the way that methane and soil moisture interact together. Maybe it's the way that methane interacts with the time of the day that cows are milked. Some of those interactions may lead to differences in the way we have policy that improves our operations. So I also wanted to point out that satellite data is easy to collect, maybe. There's a lot of it. There's a huge amount of satellite data, and it's really a great sea of opportunity for the inquisitive sailor who wishes to sail the sea of big data, including from the operational satellites presently going and future satellite missions, as well as other observations of methane that we have. So I'll stop there. Thanks all.
David, thank you. David Noon from Auckland University. That was fascinating. I felt like I was being taken on an incredible journey of opportunity. So just really wanted to say thank you. We're now going to a number of video addresses. We've been very privileged to have Mr. Vaimua Muliava, who's a member of government for New Caledonia, and also Kerry Doherty, who's a Senior Heritage and Outreach Officer for the Australian Space Agency. So look, the key point here is that the Space for Planet Earth Challenge wouldn't be possible without the collaboration of different organisations and agencies in the Pacific region. So it is organisations like the Government of New Caledonia, the Philippines and the Australian Space Agencies which help to promote the challenge and encourage students and innovators from across the Pacific to participate. So, first up to join us is Mr. Vaimua Muliava, who has extensive accomplishments in both cultural conservation and politics. He established the first maritime history museum in New Caledonia. He's held significant roles in conservation, including the head of preventive conservation at the Jacques Chirac-Branly Museum in Paris. He co-founded the political party Livell Océanien, and I'm definitely sure I haven't pronounced that well, and has won a seat in government. So delighted to have him joining us by video today. And then Kerry Doherty is OAM, is the Senior Heritage and Outreach Officer for the Australian Space Agency's Inspire program. And so this encourages space education and space awareness across the Australian community. She has extensive experience in space education, outreach, heritage preservation and exhibition development, and is the author of Australia in Space, among many other publications. So look, we did pre-record these videos just to simplify the AV streaming so that we didn't get too tangled up with technology. But we do note that all of the participants are attending this remotely. So we do say to you online, thank you so much for your time and effort in doing this.
Stay here in New Caledonia. My name is Vaimu Amuriawa. I'm a member of the New Caledonia government. I'm in charge of a range of areas, including technological innovation, which is a priority for the New Caledonia government, and of course an opportunity accelerator that underpins economic development and regional integration. I would like to thank Space Base Limited for the hard work and dedication they've shown in encouraging innovative geospatial technology among youth and entrepreneurs in the region. Their effort to democratize geospatial technology is a driver to contribute to the achievement of New Caledonia Innovation Strategy, the 2050 strategy for the Blue Economy Pacific, and of course the Sustainable Development Goals in general. The theme from this year, Space-Based Challenge, the development of a methodology to identify target areas of methane emissions, is both part of New Caledonia's commitment to contribute to the SDG and the Blue Pacific Strategy, but it is also a key opportunity for New Caledonia's youth, both high school and university students and innovative startups. Research, as you know, can be a tedious, lonely and lengthy road. Space-based challenge creates a momentum that accelerates solution-driven research by bringing innovators together to find suitable solutions to local challenges. The impact of climate-induced natural hazards and disasters is a daily reality that we have to manage. Data collection and geospatial technology allows policymakers and government to make informed decisions and to take action that are relevant and calibrated to our needs and means. The goal is to take the right decision at the right moment for the right places, for the right people, thanks to the support of the network of Innovation Center of Adec'al and its incubator. Strong value-added startups are propelled at the forefront of New Caledonia technological innovation. Ideas are incubated, tested, and entrepreneurial skills fostered so that they can become a reality that creates highly qualified jobs and generate revenue for New Caledonia. I would also like to thank the University of New Caledonia for using its networks to promote participation in the 2023 Space-Based Challenge to offer its students the opportunity to develop valuable research and technological skills. The PEPIT program at the university is one of the incubating opportunities for young entrepreneurs to develop their idea and to turn it to a practical solution. The challenge is also a valuable opportunity for participants to further refine their knowledge in a guided environment. Our shortlisted candidates will have the opportunity to be coached to develop their ideas into a fully fledged scientific method that can then be used in preparation for the launch of MethaneSat. MethaneSat is a jointly sponsored initiative from the US Environmental Defence Fund and New Zealand government. I would like to acknowledge the support and contribution of the South Pacific community in relaying the message across its networks to promote the challenge and to encourage diverse and multiple applications. It is through the diversity and complementarity of our skills, knowledge, and expertise that we will be able to solve complex problems. The SPC work in the field of environmental protection, data collection and analysis, and for the implementation of 2050 Blue Pacific Strategy makes it, along with Adec'al and University of New Caledonia, a valuable sponsor for the spread of the challenge in the tech innovation ecosystem. On the 7th April 2023, on behalf of the New Caledonia government, I signed a letter of intent with Adec'al Innovation Centre and Space Base Limited in order to substantiate our intention to support the 4th edition of the Space Base Challenge. Since then, my team and I have given several interviews for TV, radio, and the web and social media to optimize media coverage and encourage participation in the challenge. We have activated local networks thanks to the help and support of aforementioned partners and sponsors, namely the Adec'al Innovation Centre, the University of New Caledonia, and of course SPC. Each of them have actively participated in the promotion of the challenge to encourage participation from everybody, from high school and university students and of course startups. Fostering greater participation will increase the chances to find suitable, relevant solutions that can have long-term impact and benefits for the environment and the region. Once again, I would like to thank Space Base for their tremendous work and the momentum their challenge creates. I find it very encouraging that Fiji won last year's challenge, and I'm hopeful to see young Caledonian talents blossom through this competition. Go New Caledonia, good luck to everyone.
Hello, I'm Kerry Doherty. I'm the Senior Heritage and Outreach Officer for the Australian Space Agency. And the agency would like to thank Space Base for inviting us here today to be part of the kick-off for their exciting Space for Planet Earth Challenge. Now, over the past few years, Australians and our natural environment have learned only too well the damage that extreme weather events brought on by climate change can cause. We've had devastating bushfires, we've had a succession of catastrophic floods, and these have impacted on our natural environment and our national economy. They've demonstrated the need for urgent action in addressing climate change. New Zealand has also recently suffered from catastrophic climate change-induced weather events, and of course our Pacific neighbours are already having to cope with the effects of climate change through rising sea levels as well as extreme weather. We know that methane is an extremely powerful greenhouse gas that the United Nations Environment Programme has recognised as a leading driver of climate change. And the goal of the Space for Planet Earth Challenge is to use space technologies to find new and innovative ways, solutions to address climate issues in Australia, New Zealand, across the Pacific. Using satellite data in combination with data from other sources on the ground, the challenge aims to help develop new, innovative scientific methods to identify target areas of methane emissions on the Earth. Australia was a pioneer in the utilisation of remote sensing satellite data for the management of the natural environment, and this began back in 1972 with Landsat. We went on to become a leader in the development of remote sensing application software through the 1980s and the 90s. So we recognised the value of space-based Earth observations in helping to manage our environment and the resources of our vast continent. We also know that they're incredibly important in dealing with natural disasters. So today, Australia is one of the world's heaviest users of satellite-provided environmental data. And it's for this reason that the Australian Space Agency is pleased to support the Space for Planet Earth Challenge as a sponsor. So harnessing the creativity, the imagination and innovation of young people across Australasia, the Pacific Islands and the Philippines, this challenge is going to enable high school students, universities and startups to actually play a role in the identification of significant methane emissions across our region and across the world. This means that they'll have an opportunity to contribute to finding solutions for a problem that is going to impact upon their lives and futures. So collaboration across the region will actually bring to bear different perspectives and points of view that hopefully will spark new ideas, new approaches to using space technology to actually address these pressing climate change issues. The Australian Space Agency encourages schools, universities, interested individuals and startups to participate in this really worthwhile challenge. You have an opportunity to contribute to the future of the world in which you're going to live. Will you accept that challenge?
A huge thank you to Vaimua Muliava and Kerry Doherty, who have joined us online. That was fabulous. Now it is my real pleasure to be able to welcome to the stage the CEO and co-founder of SpaceBase, Emmeline Pat-Dahlstrom. Look, when I first met Emmeline a couple of years ago, I remember sitting down and she talked about SpaceBase and this vision and the sense of excitement about democratizing space and the potential. And one of the things that she could see was how Aotearoa New Zealand could be a proving ground for global impact, that what we do here has potential to change the world. So it's a real honour and privilege to introduce Emmeline today.
Thanks so much for the wonderful introduction. Kia ora, everyone. One second. I'm pretty short, so. All right. So first of all, I really, really want to thank everybody who've come here despite the kind of impending weather today. This is for the Auckland, of course, crowd, but also everybody online as well. We're really, really privileged and honored that you have actually joined us to kick off the Space Challenge for today. So you've heard from all of the speakers that methane is a really big problem. I don't have to emphasize it anymore, but I think it's a problem, but also a potential opportunity for us to actually work on it. So which is why the problem statement for this particular space challenge is essentially how do you identify methane emissions all over the earth using satellite technology or combination of satellite data and other data as well. So what I'm going to be talking about here is really the mechanics of the challenge. So in a nutshell, the challenge has like 3 stages where it includes an incubator program, an online incubator program, and then ends with basically a pitch and a demo award session in March 15th of 2024. So it's a long process. Today basically is the start of the application period for getting into the incubator program. And the prizes to be won basically is from prizes up to 25,000 USD, depending on the category. So there are two categories for the challenge. It's the high school category and also the university/startup. So the requirements are fairly simple. You can either be a high school student, so whatever level, whatever grade you are. And then for the second category is that you can be a student in university, also can be undergrad, can be graduate. And then for simplicity's sake, we said that for startups, if you are a startup or you want to become a startup, that it's not more than like 20 people in your group. So to select for the virtual incubator, basically we are doing this between now and the end of the 31st of August. And why do we do the incubator? What we're trying to do is we're trying to help the teams that are actually working on their solutions to give them some more background information, more training, more tools. We do this through online webinars. We also have some data sets and as well as potential advisors and mentors for the incubator. The requirements for going into the incubator is fairly simple. So one is like, who are your team members? So we're just asking for that. And then the second one is basically a 2 to 10 page proposal. So this is, remember, so this is a proposal, not the solution. Which then basically just explains, what technology are you intending to use, what's your potential plan and schedule, and what do you need. The second stage to the challenge is really to down select teams that will actually go into the finals. So you can either be part of the incubator and then submit the application at the end of this period, which is on the 25th of February. Or you can be a team that did not go through the incubator and just wants to submit an application. That also works. The requirements, again, are very simple. It's just a 5-minute video of basically demonstrating what you have done as a solution. And then the second one is a presentation deck of a description of what you've actually done. What we're trying to do is we're down selecting. So we're selecting for 3 finalists for the university and startup level, and then 3 finalists for the high school level. Once you actually get selected to the finals, it's already a guarantee that you're going to get some kind of a cash prize. So the finals, the stage 3, is really to compete during the demo and pitch session on the 15th of March. And again, the university startup grand prize winner will get $25,000, 6 months of mentorship, and then the 2 finalists will also get like 2,500 New Zealand dollars each. For the high school, they'll get about $8,000 New Zealand dollars in cash, and then the 2 finalists will receive $1,000 New Zealand as well. So the judging criteria is going to be similar for all of those 3 stages. I won't actually go into detail here right now. It's all on the website, and I'm also available to talk about it after the presentation. But essentially, it's like just trying to make sure that you are, using, sound science. You're using like a real new idea as well. How long does it take to implement it? And so forth. And then also you're going to be evaluated on your prototype as well. And then there's extra points for if you are actually collaborating with other organizations, or you're implementing also or including other disciplines in your solution as well. And then we're also going to be looking at the team composition. Does your team actually got what it takes to actually get it to the finish line? So after this, we're going to be doing other briefings throughout New Zealand, online, and then potentially also abroad if we get more funding. But these are the the events that are now scheduled with the dates and where they are, and we'll be announcing more as well in the future. So really, today, this is basically a provocation to all of those who are interested in applying. Actually, I wanted to point out, Jaden is here in the, he was part of the team that won the high school like category the last time. So he's from Wellington, but now he's at University of Auckland. So I just wanted to point out, so there's a lot of opportunities for participants. There's opportunities for potential mentors and speakers as well in the incubator. And then also we're looking for evaluators throughout those like 3 stages that we're gonna go through. And so that's really all for me. But before I actually turn it over back to Rosalie, I do want to acknowledge all of our sponsors and partners. We're a very small organization, and so for us, it's really just fantastic to see the outpouring of the support coming from New Zealand, Australia, the Pacific Islands, and it's just amazing to see all of these organizations kind of like really lend their hand. So to our gold sponsor, Kiwi Ventures, other sponsors, Rich Bodo via the Gift Trust, Callahan Innovation, Tipuna Atea, Auckland Space Institute, Australian Space Agency, Outset Ventures, Auckland Unlimited, Biome Trust, and the Auckland Aerospace. Thank you very much for all of your support. We also have partners as well. The government of New Caledonia, spearheaded by Monsieur Mulyava, the Philippine Space Agency, the Edmund Hillary Fellowship Institute, Adec'al Technopole, La French Tech Polynesie, CCiSM Polynesie Francaise. I know I'm basically murdering the names probably. Our marketing partners at Space Without Borders and fundraising partner Engineering Dreams. So, but last but not least as well, thank you to GridAKL for hosting us with this venue today. And of course, for our fantastic Rosalie Nelson, who's agreed to be the master of ceremonies for tonight. So thank you again, and I look forward for the applications that are gonna come in the next few months. Thank you.
Thank you, Emmeline. I'm always inspired when I have time with Emmeline and Eric. You know, when I was growing up, the idea of New Zealand having a space agency was laughable. We had literally nothing really that was in that space. And yet, within a number of years, we have created a New Zealand space agency. We have an industry that I believe a recent study by Deloitte now puts to the same value as our wine industry. In other words, this is an enormous area of potential. And what we've heard today is that if we can find ways to address the methane challenge, this will take us a long way towards helping us to achieve our global warming targets. We have here, through Methane Sat, an enormous opportunity to be able to visualize and see what is the impact, to understand the problem and to find new solutions. So it's incredibly exciting that all of you have this opportunity to be engaged in finding some of those solutions that will benefit not just Aotearoa New Zealand, but the Pacific and the rest of the world. So just really want to encourage you to put your hands up for as applicants, as mentors, as supporters. Certainly I know that we will be encouraging those in the Edmund Hillary Fellowship to do just that. So look, for those that are in the room, I want to thank everybody online for your time and for staying with us. Ka kite, and we will see you again soon. And we'd also like to invite everyone into the room for networking and some refreshments. We do need to be out of the venue by 8 p.m, but I think we can manage that. Thank you all so much. Tēnā koutou, tēnā koutou, tēnā tātou, katoa.